Hi all. Today we are going to see the topic about problems of synchronization, which comes under the subject of operating systems under the unit of process scheduling and synchronization. So let's recall the session before we enter into the new topic. Uh, Process share common resources. While the process can share the common resource, there could be race condition occur. For avoid that race condition, we are going to use the synchronization method. Some of us helps control access. So these are all the topics we are going to discussion in this session: producer consumer problem, readers writers problem, dining philosopher problems, and synchronization challenges. These are all the topics we are going to see in this session. It explored the thing. Some problems occur repeatedly in systems. So we have what we are going to do for that kind of problems. They represent real life conflicts are known as classical synchronization problem. These are all the thing we are going to explore in this session. Why we are using classical problems? Generally, before we are going to see why we are using classical problems, we have to know what is synchronization. While one or more process can uh, require the same resources, we can't acquire the resources to a single process. So we have to assign that resource to a process based on some criteria. For that only we are using synchronization. So it's used to test solution. It's foundation for OS design. This is classical problems, and classical synchronization problem is it is a standard OS synchronization problem. It is used to model shared resource usage, and the synchronization problems can solved by using semaphores or monitors. Um, this is the producer consumer problem. Here, producer can create items, consumer can uses that particular items which is produced by producer, and shared buffer is in between. So here, while buffer is overflow, we can't produce the new items. While buffer is underflow, we can't consume that particular product. So this is requires synchronization. The second problem is readers and writers problem. The same as like of producer consumer problem. Here, multiple readers can allow to read, but only one writer at a time can write that particular thing. So writer needs exclusive access. While writer need that particular access, the another readers cannot override that thing. They can only access to read. This is the reader-writer problem. And here, reader is the reader starvation, writer starvation. Fairness issues is happened here. Here, there is a shared resource. If a writer is entered to write the thing in that resource, the another process can only read that particular resource. They can't override the same thing here. So while when the writer leave that resource, the another readers can write the thing in shared resource. Dining philosopher problem. Dining philosopher means it's shared chopsticks. Need two to eat. Deadlock is possible. There are the issues while using dining philosopher. That one is deadlock, another one is starvation, and resource contention. Dining philosopher is there are five philosophers are there. Each philosophers can have the two chopsticks between two philosophers. A single chopstick is placed in between two philosophers. Uh, each philosophers can eat the food by using two chopsticks, but one philosopher can access the one chopstick. The another philosopher cannot access that particular chopstick. This is the dining philosopher issues. It may lead to deadlock and starvation and resource contention. So solutions we are going to solve this dining philosopher and producer consumer and readers writers are semaphores, monitors, and mutex locks. These are all the solutions we are going to use it to solve the classical problems. And real world applications in the classical problems is database systems, operating systems, and multi-threaded programs are the real world applications for the classical problems of synchronization. So let's summarize this session. What are the classical problems? Classical problems are there are three types: producer consumer, dining philosopher, and reader status problem. And model real world situations are database systems and operating systems. There are the multi-threaded systems are the model real world situations. And solution we sure ensure correctness is mutual exclusion and monitors and mutex. These are all the solution. Thank you.